Welcome back. We're going to have an R session now, this time on model selection. So we've got a script ready. We're going to look at using validation sets, cross-validation for selecting the tuning parameters in stepwise regression, lasso, ridge regression, and the like. This will be broken up into a few sessions. And we're going to do something a little different this time. In the past, I've just shown you an R script that we've used in RStudio, where we click through the commands. Well, this time we're going to do it in also in RStudio, but using something called Markdown mode. And what that is it's a way of merging text with R code, and at the end of the day, you can produce a document, in this case, a HTML document or a web page. And as you'll see, it's just about as easy to do as using a script, and it just becomes much more useful, especially for making demonstrations. So let's see how this works. Okay, so here's our Markdown script. It's the beginning of it. And you'll see it's got actual just text written in the beginning that says this is an R Markdown document, and it's got model selection at the top. And it's underlined with equal signs. And there's a few conventions in Markdown. I'll just click this help pane over here, and you see very simple instructions on how to structure Markdown on the right. So it's very easy to learn. And the R code actually sits in chunks. And so here's a chunk over here. And we just execute code in the chunks just like we did before. Notice the chunks begin with this back quote, back quote, and then R. It's a little incantation, which you can invoke by using a keystroke. And we execute the commands just as before. So here we are. We go library hit ISLR, and we're going to use the hitters database, which is a baseball database, which has a recording of a whole lot of statistics for different baseball players, and including a response variable, celery, which we're going to use as the target for a regression model. And so there we see celery. We notice it's got a bunch of missing values, 59 missing values, which is going to be a little unpleasant for us. So we're going to do something about that. But just for the moment, look at the summary, and you can see all the names of the variables. These are statistics that have been collected during the baseball season. And we're going to try and use these statistics to predict the salary of the player. So missing values there are various ways of dealing with them. We're going to take the easy way out here, and we're going to eliminate any row in the data frame that's got a missing value in it. And there's a nice function called na.omit that does that for you. And we run na.omit, and that'll produce a new data frame, which we just overwrite on hitters here. And it won't have any missing values. It'll have less rows, of course. And then we can just check if there's any NAs in this new data frame hitters. And here we use our with function again, because it's kind of cute. So with data frame hitters, look at the sum of is NA. Are there any NAs in the variable celery? And when we do that, we get 0, which is what we expected. Okay? All right, so the first thing we're going to do is we're going to see how to do best subset regression. So if you recall from the lectures, best subset regression looks through all possible regression models of all different subset sizes and looks for the best of each size, and so produces a sequence of models which is the best subset for each particular size. Okay, and that sounds like a lot of work, but luckily we've got a library called Leaps that'll do that for us. And there's a function in Leaps called reg subsets that'll do that. It will do the best subset modeling for us. And so here we assign to reg fit.full this reg subsets. With celery as a response, it takes a formula, and the data is hitters. And it's amazingly fast. We've got over 200 baseball players here, and it did all subsets, and we got 19 variables, and it did all subsets regression in no time at all. And if we do a summary, we get a kind of printout that summarizes the best subset models. And what it does is, for each subset size, so for example, subset size 1, it puts a star next to the variable that's in the best subset of size 1. So that's CRBI. And then the best subset of size 2, of course, there's going to be 2 with stars, and 3, and so on. And for the beginning, it looks like these subsets are nested, but they don't have to be nested. And if you study this output, you'll see that at some point they're not nested. And so that's one way of looking at our best subset. By default, it only goes up to subsets of size 8. Maybe that's why it was so fast. But we've got 19 variables, so we're going to actually go all the way and get best subsets all the way up to size 19. So we'll run that one. Well, that was just as fast. It's instantaneous. And if we do the summary of that, well, we didn't print it out, but we ran the summary, and we'll and then we'll look at the beg your pardon, names on the summary. And the summary, we've just now printed the summary, but this tells you what's on the summary. And it has various things. Like for each of the models, the best subset models, it has the R squared, the residual summa squared, the adjusted R squared, the CP statistic, the BIC statistic, and a few other things. All the things that we're going to use to help us select the particular model. So happily, there's a plot method for well, actually, there's not. We're going to plot the CP component of reg summary. We'll just make our own plot. There it is. And remember, CP is an estimate of prediction error. And here it's plotted. We plotted it against the number of variables and the CP statistic. And the idea is to pick a model with the lowest CP. Well, in this case, it looks like the model with 10 variables is the smallest, and we can just use the function which.min to identify the smallest index of the smallest element of the CP component. And let's just annotate our plot by indicating the point that we've chosen, the best subset model. There we used points to color the point red, the one that's going to be the chosen model. So that's pretty straightforward, using CP to do best subset selection using the function reg subsets. There is a plot method for the reg subsets object. It wasn't the one that we just produced. So let's use it. And it's like a pattern picture. And at first, you have to figure out how to interpret this plot. What it shows is, on this axis here is the CP statistic. Small is good, so this is the smallest CP. This will have corresponded to our model of size 10. And then you see CP getting worse and worse. And then for each value of CP, or each unique value of CP, black squares are ones indicating that variable's in, and white squares are the variables are out. Okay? And so it's an interesting picture. So what you notice is near the bottom of the CPs, the models are reasonably stable. Like this whole band stays the same. There's a little bit of fluctuation over here. What you also notice is that, as we should expect from that previous plot, that bad CPs corresponded to models that had all the variables in, or ones that had hardly any variables in. And so, you get used to interpreting this plot. And it sort of gives a quick summary of all the models, as opposed to just seeing the CP statistics. And now, having chosen model 10, there's a coefficient method for reg subsets, and we ask it for the coefficients for the model indexed 10, and we get a coefficient vector, and it gives you the coefficients of those 10 variables that are in the model. And there they are. Okay, well, so that's the end of the first little session. We'll carry on with subsequent sessions using different methods for model selection. Before we leave, I want to show you how you actually get a nice summary, the HTML file of everything that we've done so far. So you'll notice at the top here, there's a command knit HTML. So we're going to issue that. And it shows us, this is the web page that shows us everything that we've done, but it's formatted nicely. So we get all our commands, we get headings, the model selection, we get our commands, the text is nicely formatted, and we also get the output. The R output is commented with 2 hashes on the side, and then any graphic that we produced also appears in this plot. So that's a very nice way of retaining everything that you've done in the R session.